Welcome to Semantic Web Technologies. This is Lecture 6, Applications in the Web of Data. And today we want to talk about semantic search, which means we want to improve web-based search or traditional keyword-based information retrieval with the help of semantic technologies. Just remember, in keyword-based search, we are dealing with symbols, most times with natural language. And in natural language, you had the problem that, of course, this term in a language stands for an object of the real world, but of course, these terms can be ambiguous. And it depends on the meaning and the mapping to the right concept, to the right ontology, to the right knowledge representation, whether sender and receiver in the communication are able to communicate and are successful. And they have to refer, of course, to the same concept. So this is quite important because it makes a difference here. For example, if you're talking about Neil Armstrong or if you're talking about Lance Armstrong. Two different persons, two different situations, and complete different meaning. You see, in a search engine, for example, when you look for Armstrong and you do here the Google image search, you will find lots of pictures of, as you can see here, Lance Armstrong, because he was popular in the media in the last months. And you will also find some pictures of Neil Armstrong. And you will nevertheless find pictures of Louis Armstrong or people that are somehow related to somebody named Armstrong. So this is the way how Google searches for multimedia or for images. But we will come back to that later on. So for us, it's important that whenever we are talking about Neil Armstrong, we are referring to an entity and knowledge related to that entity. So we are talking about Neil Armstrong, and we always have the URI of the information resource in the World Wide Web that has or that gives us metadata, information about the object we are talking about. So this is quite important, and we want to apply this concept in information retrieval. So let's go back to traditional information retrieval or classical information retrieval. How does it work? So in general, you have a set of documents, which are files of records. And on the other hand, you might have information requests, so a set of queries. And the problem now is you have to match these queries to your documents. So you have to find which documents really fit to the queries that you have. For that, you do the following thing. In principle, you index your documents, and on the other hand, you formulate a query in some kind of indexing language, so that in these two representations, so there is a transformation in representation on both sides, then in the indexing language, you can do a similarity-based search approach or mapping approach. You try to map these queries against these documents by some kind of similarity measure, which is, for example, also string matching or equality or a fuzzy kind of string matching and stuff like that. So in information retrieval, what you have a search query, and you have this set of documents, and then you have a large index where the document has been translated into a format that can be mapped against the search query. And therefore, you look up the search query here in the index to find which document belongs or refers to or has to do something with my query. Now, you have to consider how the quality of the result that the search engine gives you back. So quality measures for the evaluation of information retrieval systems are quite old, so the two most important ones are recall and precision. You might have heard about that. So what is recall, what is precision? So first of all, you have to define these two sets. You have the relevant documents, which would be the right answer to your question, and you have the retrieved documents. These are the documents that the retrieval system or the search engine really returns. And in the ideal case, they should have, of course, some match, and the match or the intersection of both that are the relevant documents that have been really retrieved by your retrieval system. So in the ideal case, these two sets would be the same. But usually you will miss something that you do not find, or you will find something that does not belong to the really relevant document. And therefore, of course, you can measure how much is the amount of relevant documents that really have been retrieved or really have been found. So first of all, you have here the recall, and the recall is nothing else but here you take the number of relevant documents that you have retrieved, and you divide this by the number of relevant documents. If you have found all relevant documents, then this, of course, the recall is 1. On the other hand, you have to look at the precision. The precision says you take into account the number of relevant documents that have been retrieved, and you divide this by the number of all of the retrieved documents. In the ideal case, there are only those documents in the retrieved documents that do really matter. But sometimes you might have found some documents that do not really matter, and then this precision value is somewhere between 0 and 1. So recall stands for the completeness of your search result, and precision stands for the accuracy of your search result. And you can combine both measures into a harmonic mean of both of them, and this is called the so-called F measure, and with the F measure you comprise both values, the recall and the precision, into one value. And this again is a value between 0 and 1, and the closer these values are to 1, the better are these search systems in general. Okay, this so much for the evaluation. But we have to take into account now we are able also to apply semantic technologies for search technology. So we have to define what does semantic search really mean. And for semantic search, if you look it up on the web, you will find lots of definitions. So for our purpose, we refer to semantic search when we have text-based metadata annotations, and they are annotated with semantic entities. It means, for example, we have text, or we have pictures, or we have videos, and they are annotated with metadata, and this metadata refers to semantic entities which have a connection to an ontology, which is a knowledge representation, and which tells you about the meaning of these things. So we are not anymore talking about so-called keyword-based retrieval, because we do not look for things or mappings, matches within the strings of the language. We looking for entity-based information retrieval. It means in our query, we phrase our query in terms of entities that we are looking for, and the answers will also be documents that are annotated with entities. And when these entities are found in these documents, we will give back these documents that we have found. So what we can do furthermore is we can make use of semantic relationships, for example. So content-based similarities, for example, can make sense. So I can also give back not only exactly matching results, but results that are somehow related or somehow similar to my query. And then, of course, this metadata via semantic annotations is, of course, interoperable. And I can use this for content-based description and also for structural technical descriptions. So the overall goal of semantic search within our purpose is to improve the quality and the quantity. So a quantitative and a qualitative improvement of information retrieval. It means more complete and more precise results. We want to increase first the recall, and we want to increase the precision. And we do this by mapping our information resources against semantic entities and by applying semantic search. It means entity-based search on our documents, on our semantic annotated documents. And this results into an improvement of recall and precision. And this would be some kind of semantically enhanced classical information retrieval. So let's take a look which points within information retrieval semantic technologies fit in for the improvement. So first of all, we have the possibility to extend or to refine the traditional query string to enable more precise and more complete search results. We will go into these points in detail afterwards. Then secondly, we also have the possibility to determine cross-references to complement our search results with additional associated or similar information which would be useful for the user. And moreover, we can enable something which is called exploratory search, which means we can show new paths or new ways within our huge repository of information and knowledge that we have. So for example, in the web, there are so many documents, it's really difficult, for example, to get an overview, or it's really difficult to navigate between these documents. Of course, you have links, but if you follow links, they are not topic-based, for example. You have not the possibility to follow a link according to a topic. So this would be something that exploratory search, for example, enables. And there you will have means for visualization and navigation of the entire search space. And at last, of course, we also can apply reasoning. So maybe some of the results that are possible and are relevant are not really obvious. And you have to think about, you have to really enable reasoning, entailment to infer or to deduce the results that are based on implicitly given information. So this would be really the last thing to do. So this is also the most, let's say, complicated thing to enable reasoning to complement the search process. But this is also of importance, of course. Let's take a look at the single points in depth. So first of all, I can, of course, extend somehow the query string. Why is this useful? If I think about keyword-based search, then we know that this does not deliver all possible search results that are relevant for a query simply because synonyms, metaphors, or anything might use to describe the queried content. So what I can do is I can extend my original query with terms that stem, for example, from dictionaries or thesauri. So I can use synonyms that come from a dictionary. I can use hyponyms. Hyponyms are some specialization of terms, and I can connect my original terms with them. And I can also make use of domain ontologies where I can find so-called meronyms, so parts of my object, or related concept, and I can use these terms that I find here to extend my query string with a simple OR combination. So for example, when I look for bank, then I'm not quite sure that I really find all possible depository financial institutions that I'm referring to with the word bank. So I might also look, for example, for credit union. I might look for Federal Reserve and stuff like that. So I can simply look it up in the dictionary or in the ontologies. What else? What labels do I have? What synonyms do I have? What hyponyms do I have? And I simply add them to the query string to get a more complete result so that I'm also able to find results where these words are located in. So this is not, let's say, a complete semantic search process. This is a simple extension of the keyword-based search process with semantic technologies that are based simply on query extension. So this is the extension of the query to get a more complete result. But I can also use the extension to get more precise results. There I simply connect my terms with a logical AND operator, which means that both must occur within the document I am looking for. And then I will get much, let's say, more results that are much more precise. So then the document terms, of course, they are ambiguous, and the problem there is in the keyword-based search that the search results, there are search results within my results that are not really relevant for the query because I had something else in mind, and the search terms were ambiguous. And I try to disambiguate the search terms to refine the query string simply also by looking up in a dictionary, and there I can look, for example, for hypernyms, which are generalizations of the terms I am using. Therefore, I can disambiguate polysemic terms with hypernyms. And I can also look up in the domain ontology, for example, holonyms, which are in a part of relation, the thing where my query string would be a part of a much general, a much larger thing. And then I connect simply, as you see here, for the 4 different meanings of bank. In the first case, I connect bank with financial institutions. And then in the first query string, it will be much more, let's say, unlikely that I will find things that will refer to a container, to a slope, or to a deposit, for example. Again, also in the second example, I can combine bank with incline, slope, and site, and then I will end up in some geographical or let's say something that has nothing to do with financial institution and container. And of course, bank can be referring to a container, bank can be referring to a deposit or repository. So what I do here is I use these terms, which are mostly generalizations, so hypernyms or so-called holonyms. I connect them with a logical AND with my original search string, and then I will get more precise results.